and all the parents, family members, and friends for attending here today for your support and encouragement. Finally, I would especially like to thank the students for their hard work throughout the courses and their careers here. It takes a lot of time and effort, often working very, very late into the night to prepare the course, refine the materials, develop the most revealing examples, answer all the questions, and grade the assignments. Your accomplishments and your appreciation today make my efforts so worthwhile. Being a successful scientist requires tremendous intellectual ability and creativity, sometimes requiring that you apply completely counterintuitive ideas to advance. Consider, for example, the process of forging and manufacturing soft iron ore into hardened steel. Iron in its natural form is not strong enough for creating the tools or buildings or machines that we've come to depend on. At the beginning of the Iron Age, though, it was discovered that if you mix the iron ore with brittle substance carbon and then repeatedly superheat it, hammer it out, forge it, the end product, the hardened steel, would be much stronger and sharper than the raw elements. Surprisingly, the hotter you heat it, the harder you hammer it, the stronger it would become. Today, we know this process of annealing actually aligns the crystals, the molecules inside the iron, into its hardest and strongest possible shape. Through science, we have come to understand this process, but it must have been a true leap of faith for those early scientists to discover that superheating and hammering the ore would make for the hardest steel. Beyond intellect, though, becoming a successful scientist requires tremendous personal strength and perseverance. We scientists spend almost all of our time in a state of questioning and maybe even confusion. What is the next experiment we should do? Why did this experiment fail? Was the temperature in the room too hot, too cold? Do we need to increase the concentration of the reagents? Do we need to decrease them? Is there another experiment to do? Or even sometimes, why am I studying this in the first place? These are all very big questions that can be very hard to swallow sometimes. Very few people choose this path, and even fewer persevere through the confusion and inevitable setbacks to reach where you've made it today. Earning a PhD from Cold Spring Harbor Labs is an irrefutable statement that you have the ability to take an idea, refine it over many years, overcome all the challenges, and answer deep questions about the nature of the world. This is a truly awesome endeavor and an incredible day for you all. Now, I wish I could say that a PhD would somehow mean the process would be fundamentally different and a lot easier now, that you wouldn't face those same challenges and setbacks. I wish I could, but unfortunately, those challenges are fundamental to the nature of discovery and science and are always present. Instead, when you do face those challenges, I encourage you to come back to your home here and talk to us. We will forever be behind you to make sure you're on the right track and support you however we can. But more importantly, look within yourselves to ask yourself, what is the right approach to solve this problem, regardless of how difficult it may seem? If it seems difficult, just remember the long hours you have spent in the courses, completing problems, studying papers and for exams, writing and defending your dissertations, and especially the sweat you have shed in the labs. Much like superheating and hammering the iron ore, all of that intense effort has annealed your minds into some of the strongest and sharpest scientists in the world. I have confidence in you that you can accomplish any goal to which you set your mind. Thank you, and good luck to you all.